Hi guys, welcome back. Today I'll be covering integration by partial fraction. So in the last video, I explained how you can use integration by parts. Don't forget the two principles again. That is when you have integral of this form. So whereby if you differentiate the denominator, you are going to have the numerator. It's the same thing as ln f of s plus c. Likewise, when you have this type of integral f prime of s multiplied by f of s, the same thing as f of s everything squared divided by 2 plus c. You understand? So if that is understood, so let me give you an example so that it leads to integration by by partial fraction. So suppose you want to integrate this integral 2x plus 5 divided by x plus 1 s plus 3 with respect to s. Okay, now let me ask you, if you differentiate the denominator here, are you going to have the numerator? So it is not possible. Okay, we can try it. You know, your s plus 1 s plus 3 will give you what? X squared plus what? Plus 6s plus 3. You understand now? You know, if you integrate, if you differentiate this, you are going to have 2s plus 6, not 2s plus 5. So it is not possible. So, and you will see that this is an example of a partial fraction. You can resolve this into partial fraction. What is partial fraction? Take for example, if I have 1 divided by x plus 1 plus 2 divided by s plus 3. You know, we can solve this. If you want to solve this, you are going to have your LCM, you are going to find your LCM, which is s plus 1, s plus 3, right? And this one will give you s plus 3 when you divide this by this, s plus 3 plus 2 into s plus 1. That will give you s plus 3 plus 2s plus 2 divided by s plus 1, s plus 3. And that will give you what? 4x plus 5 divided by s plus 1, s plus 3. So the process of taking this back here is called what? Partial fraction. So when you these two fractions are partial fraction of this. You understand now? So if you are resolving it to have this function, to have these fractions back, then we say you are resolving partially. Okay, now let me just change this to 4s and let's see what we have. So in essence, when you have this type of integral, it means you have to resolve partially. So then you now integrate. So when the two principles, that of division and that of product, if they do not work again, okay, let us do that. And don't forget, in your partial fraction, before I even solve it for you, don't forget some of the rules. You will have been taught this in your high school. The first rule when you are solving partial fraction is that the degree of the what? That is, your numerator must be of lower degree than the denominator. For example, you know, for 4s plus 5 here, we have that the numerator is having what degree? That is 1. Degree is 1 here. And the denominator is of degree 2. So before you can resolve it partially, then you must have the degree of the numerator, you must have it less than the degree of the denominator. So that is, it has to be proper fraction. It has to be proper fraction. So that's the first rule. So, but if it is the case that the denominator is of degree lower than the numerator, that is, when you have that your degree of numerator is greater than that of the denominator, which is what? Improper fraction, then you have to reduce by long division method and factorize to its you have to reduce by long division method and write your remainder plus so what you have. So after that, then you have to factorize to their prime factors. So for example, if you are having a linear factor like this one I have here, so if you have a linear factor as plus b, so then don't stress yourself, you are going to have a into what? As plus b. That's the general partial fraction for that. In essence, for something of this nature, 4s plus 5 divided by s plus 1, s plus 3, then you are going to have that a divided by what? S plus 1 plus b divided by what? S plus 3. So that's when you have linear factor. At times you may have a repetitive factors at the denominator. For example, when you have something of this nature, as plus b squared, you don't need to stress yourself. Then the general partial form of this will be what? A divided by as plus b divided by what? As plus b squared. In essence, if I have 4x plus 5 divided by s plus 1 squared, then if you want to resolve it partially, this one will be a over as plus s plus 1, a over s plus 1 plus b divided by s plus 1 square. Even if it is raised to power 3, then you are still going to have plus c over s plus 1 raised to power 3. That's for repetitive fraction. You understand? In essence, if you have your denominator as this, then I'm going to have a over as plus b, like I've explained the other time, plus b over as plus b squared plus c over as plus b raised to power 3. So likewise, we have quadratic factor at the denominator. So when you have ax squared plus bs plus c at the denominator, then you don't need to stress yourself. Then you are going to have something of this nature: as plus b, ar squared plus bs plus c. We notice that in denominator here, you have a 1 degree lesser than what you have as your factor here. In essence, when you have factor, so which degree is what? Degree is n. Then at denominator here, you are going to have degree n minus 1 divided by what you have here, which is your degree n. You understand? Okay, now it is now time for us to solve this type of question. Once you know, since you know already the rule of what? Partial fraction. So we have 4s plus 5 divided by s plus 1, s plus 3. Suppose you have that type of integral 4s plus 5 divided by s plus 1, s plus 3 with respect to s. First step is to resolve this partially first. This one. Say resolving 4s plus 5 divided by s plus 1, s plus 3 partially. If you resolve it partially, you know, you have your you have the linear factor. So since you have the linear factor here, then your 4x plus 5, s plus 1, s plus 3, since we already observed that our degree of denominator is also what? Lesser than the denominator. So then I'm going to have a over s plus 1 plus b divided by what? S plus 3 with respect to what I explained the other time. So immediately you have this. So since we want to get rid of this guy, then you can say multiply through by s plus 1, s plus 3. Then I have 4s plus 5, s plus 1, s plus 3, s plus 1, s plus 3 is equal to a over s plus 1, s plus 1, s plus 3 plus b divided by s plus 3, s plus 1, s plus 3. You understand now? So these two guys will cancel each other, x plus 1 will cancel this. So then you have 4x plus 5 is equal to a into x plus 3 plus b is equal plus x plus 1. So you have different types of method to find the value of your a and b. You know what we want to know is our a and b, and you can get the value of your a if this guy is not there, and you can get the value of b if this guy is not there. So one of the method is to use elimination method. You have cover up method, and you have comparing the coefficients. So I will use the one that is simpler for you. Number one, you can use your cover up method here. That is, you eliminate this guy, you understand now, to get this guy, or eliminate this guy to get this. So for example, if I want to eliminate a, you know, the moment this expression is equal to 0 and you multiply 0 by a, it will go. So what will be the value of s such that this expression is going to be 0? That is, when you have s plus 3 equals 0, then the value of s such that this is going to be 0 is minus 3. So if you now put s equal to minus 3, because we are interested in eliminating this, if you want to eliminate this, you can put your s to be minus 1. So then you have 4 into minus 3 plus 5, a into minus 3 plus 3 plus b into minus 3 plus 1. So minus 3 times 4, that's minus 12 plus 5, right? That's 0 plus minus 2b, right? So and minus 12 plus 5, that will give me what? What is minus 12 plus 5? I think that is minus 7, right? So this is 0 already. So then I have what? Minus 2b, so which implies that b is equal to, so b is equal to 7 over 2. Am I correct? Minus 7 over 2 is equal to 7 over 2. So hope we didn't make any mistake. Yeah. Okay. Likewise, you can put your s is equal to what? Minus 1 here, because we want to eliminate this guy. So if you put your s to be minus 1, then I'm going to have 4 into minus 1 plus 5 is equal to a into minus 1 plus 3 plus b into minus 1 plus 1. And this one will be 0, right? Then I have 2a here, right? Then this will give me what? 4 times minus 1 is minus 4 plus 1. That's 1. Then you have your a to be what? To be half. You have your a to be half. I hope we didn't make mistake here. Let me check it again. You have minus 3, 0, minus 12 plus 5. So that's minus 7. So yeah, no mistake. Okay, now since we know that 4x plus 5, we know already that 4x plus 5 I want to write the question again. Yeah. 4x plus 5, x plus 1, x plus 3, x plus 1, x plus 3. When we resolve it partially, we said it is a, it will give rise to a over x plus 1 plus b divided by x plus 3. Now I know the value of my x plus 1. So, sorry, I know the value of a. You know a is what? 1 divided by 2 divided by x plus 1, right? Then what did we obtain for our b? Our b was 7 over 2 here. And this will also give me 7 divided by 2 x plus 3. You understand? So then you can conclude adequately that therefore is 4x plus 5. Sorry, 4x plus 5. So 4x plus 5 divided by x plus 1, x plus 3 is going to be 1 over 2, x plus 1 plus 7 over 2, x plus 3. So we've resolved it partially. But the question initially asked us to find integral, not that we should resolve it partially alone, the x. So that will give you integral. You know, we've obtained here that 4x plus 5 gave this, right? Then I can have 1 over 2 x plus 1, your linearity property, you put the s here, plus integral again, 7 over 2 x plus 3 ds. So x plus 3 ds. And don't forget, when you are integrating with respect to a particular variable, you take out all the constant. Then this is the same thing as 1 over 2 integral 1 over x plus 1 dx plus 7 over 2 integral 1 over x plus 3 dx. And don't forget, what is integral of 1 over x plus 1? Remember, I told you if you have integral in terms of fraction, just check the denominator. Whether if you differentiate it, you are going to have your numerator. You know, you have x plus 1 here. If you differentiate x plus 1, it's going to give you 1. Then you are going to have this integral as ln x plus 1, then plus 7 over 2. Check whether if we differentiate denominator here again, we are going to have 1. Yes, derivative of x plus 1 is 1. Then this also gives me x plus 1 ln x plus 3 plus c. Can you see now? So it is as very simple as this. It is as very simple as this. Let me give you another example which is more complicated. Number 2. Find integral of x squared divided by x plus 1 x minus 2 squared dx. Don't forget, the first step is to resolve x squared divided by x plus 1 x minus 1 squared partially. And from the rule I wrote the other time, interestingly, the degree of the numerator is lower than that of the denominator. Then if you want to resolve this, so what will be the partial fraction? The partial fraction will be of the form, you know, this is a linear term, then you have a over s plus 1, then plus this is a linear term with repeated fraction, then you have b over s minus 1 plus c divided by s minus 1 squared. Understand? You now multiply through by s plus 1 s minus 1 squared. So then you have s squared into s plus 1 s minus 1 squared multiplied by s plus 1 s minus 1 squared equals to a into s plus 1 s plus 1 s minus 1 squared plus b, that will give me s plus 1 s minus 1 squared, then plus c s plus 1 s minus 1 squared. This guy cancel each other, this cancel this cancel one of these, and this cancel this. What do you have left? You have s squared is equal to a into s minus 1 squared plus b s plus 1 s minus 1 plus c s plus 1. So you know we want to find the value of a, b, c here. You understand now? So for example, based on the example I gave in the last question, here I can put my s equals 1 such a way that if I substitute it here, this guy will vanish, this will also vanish. So if we put s equal to 1, then I have 1 squared is equal to a into 1 minus 1 squared plus b into 1 plus 1, 1 minus 1 plus c into 1 plus 1. So these two guys cancel, is equal to 0, sorry. Then you have 1 is equal to 2c, which implies that c is equal to half. Likewise, if I put my s equal to minus 1, then that's going to be minus 1 squared. This guy will cancel, right? Sorry, If you put -1, that will be a into -1 squared plus b into -1 plus 1, 1 -1 minus 1, c into -1 plus 1. So these two guys will also be 0 since -1 minus 1 is 0. This will be 0, this will be 0. Then you have 1 is equal to -1 minus 1, that's -2. -2 square is 4. You have 4a, which implies that a is equal to 1/4. But we are left with what? With b. So, and we don't know what else to substitute such a way that we are going to have that. We are going to have the value of b. So, and that is where you are going to use your comparing the coefficient method. You understand? It is not difficult. What you are going to do is to expand your right hand side and you compare the coefficient in the both side. So if I expand this, you know expansion of this is nothing but what? Okay, x square is equal to, this one will give me a, that's x square minus 2x plus 1. This is the difference of 2 square, that's b square minus 1, right? Plus cs plus 1. If you like, you can expand further. This will give me a square minus 2as plus a plus bs square minus b plus cs plus 1. You understand now? So we can compare the coefficient, comparing the coefficient. So since the highest power here is 2, then you can compare with, degree 2. What is the coefficient of s square here? You know it is 1 equals to, what is the coefficient of s square here? We have a plus b. You understand? You can still take that of x. Actually, since we know my a and c before, this suffice to find the value of b. But in case of another time when you want to solve this, let me just explain. So the coefficient of s in the left hand side is 0. So then in the right hand side is -2a plus c. You understand? And you take constant as well. The coefficient of constant on your left hand side is 0, and on the right hand side it is a minus b. So it is a minus b plus what? Plus 1. A minus b plus 1. Okay, now, so since I have, you can name this equation 1, equation 2, equation 3. So from equation 1, before that, I found that my a is equal to 1/4, right? And c is equal to half. So from there, I can say let a is equal to 1/4, maybe from equation 1, right? Then I'm going to have 1 is equal to 1/4 plus b, which implies that my b is equal to 1 minus 1/4, which is equal to 3/4. So then we can conclude that my a, therefore a is equal to 1/4, b is 3/4, and c is equal to half. You understand now? And if you go back to your question, we have something of this nature, integral x squared. Sorry, before the integral, my pen is rolling. Just a minute. Just a minute, please. Oh, okay, let me just clean this. So, we have that x square. What we were resolving partially was, doing nonsense. Okay, we have x squared divided by x plus 1, x minus 1 square. And we said it's going to be a over x plus 1 plus b divided by s minus 1 plus c divided by s minus 1 squared. Okay, if you now substitute, then I'm going to have 1 over 4 s plus 1 plus 3 over 4 s minus 1 plus half s minus 1 squared. You understand? So if I now want to integrate, therefore integral x squared divided by x plus 1 s minus 1 squared ds. Don't forget your linearity property. This is going to be 1 over 4 s plus 1 dx plus integral 3 over 4 s minus 1 dx plus integral half s minus 1 square dx. You understand? So then if you collect the like terms, sorry, if you factor out the constant out, then I'm going to have 1 over 4 integral 1 over s plus 1 dx plus 3 over 4 outside here, 1 over s minus 1 dx plus half integral 1 over s minus 1 square dx. Okay, let us integrate. Don't forget, when you have your denominator and you integrate it, you have your result at the numerator. So this will give me ln s plus 1, because if I differentiate s plus 1, I'm going to have 1. So which give rise to one of the principle I told you already. Then plus 3 over 4. Likewise, if you differentiate, this is going to give you 1. Then this is going to be s minus 1 too. Then plus half. If you differentiate this, s minus 1 square, are you going to have 1? No. So then you can write this as s minus 1, everything raised power minus 2, right? So with respect to what? Sorry. With respect to s. With respect to s. Okay, if I take another line, then I'm going to have 1 over 4 ln s plus 1 plus 3 over 4 ln s minus 1 plus half. So what is integral of s minus 1 raised by minus 2? If you use substitution method, differentiate this first, that will give you 1. Then integrate all of them, that will give you s minus 1 minus 2 plus 1 divided by minus 2 plus 1. So then you are going to have s minus 1 raised by minus 1 divided by minus 1 plus c. Then you are going to have 1 over 4 ln s plus 1 plus 3 over 4 ln s minus 1 minus half, abi? So s minus 1 raised by minus 1 plus c. So and finally you can rewrite it. So this will give me 1 over 4 ln s plus 1 plus 3 over 4 ln s minus 1 minus half into s minus 1 plus c. So and that's the result. That's how you can resolve partially and solve integral involving partial fraction. If you understand this, please kindly like it. Don't forget to subscribe as well. Inform your friends to do so. So I will be meeting you in the next video. Thank you.